Okay, so final assignment for this course it's kind of it replaces the exam. So in this final assignment, you should demonstrate your skills from this second teaching period, but also including the first teaching period skills. So basically, you need to submit something for the final assignment in order to pass the course. And then, but of course, if you have done all the exercises, most of you have done them excellently. Point in the weekly exercises was that you learn to do the things, and here then you demonstrate the skills. You can complete the final assignment mostly kind of recycling code from the weekly exercises, applying it a bit further, or if you have time and interest, you can of course develop something on your own. Deadline, important. So I have this approach of using 2 deadlines. It worked quite well last year. So first deadline will be at the end of the year. Feel free to complete earlier if you want. So it's not, the point is not to spend 1 month working on this assignment, but knowing that this is not the only course you're taking, and already as such, this is quite a laborious course. So I assume that at least until Christmas, you will need these 2 weeks to work, and I won't be grading the assignments. Before New Year's, I'm planning to have a holiday. So that's why the first deadline is on the 1st of December. But if you also want to have a holiday and you don't finish this assignment quickly, it's equally okay to then submit for the second deadline, which is on the 15th of January. So choose one of these, and then I will check at each deadline who has completed the assignment, and then I will do the assessment kind of in these 2 batches. Yeah, so of course it might be that those who submit in the earlier batch might get a bit more feedback, but of course I will do the assessment according to the same criteria for everybody. Yep, and in case there's somebody who, if you're an exchange student or for some other reasons you really would need the grade fast, then please contact me. So of course there's 50 students, but for some in the priority order I can do the assessments then even before Christmas if needed. Yep. So if there's any questions about this, so the second deadline is rather strict. For your information, I will switch jobs at the start of February. So then after that, of course, if you have done all the work and then for some reason can't submit, we should then discuss how you can complete the course if you don't make it to the second deadline. Just a recap of what were the learning goals and topics. So we have learned and what skills should you demonstrate in this final exercise. So Shapely, modifying, creating geometries using Shapely, and then combined with GeoPandas, all the GeoPandas skills and tools and tricks, building on your Pandas skills from the first teaching period. Then geocoding, spatial queries, well, not to forget also coordinate reference systems. It's kind of underlying all these things on from week 2. Then reclassifications, overlay analysis, visualization, both static and interactive maps. And also don't forget these kind of spatial visualizations. So it's often good to, depending on the topic, you can also plot a bar graph or some other type of visualization in addition to maps. Then we learned last week how to fetch OpenStreetMap data and network analysis. So that as such can be one topic for the final assignment. And indeed, then there are these extra materials if you want to study those. So let's say if you would choose to work with raster data, then maybe my expectations of the kind of, let's say, size of the problem that you're solving can be then a bit lower. If you're kind of investing your time in learning new tools not covered in these 6 weeks. Yep. So you should be able to write modular code. What we mean by that, so try not to repeat yourself and try to write the code, well, shorter is not always better, but as efficiently as you can. But then again, if the iter rows in pandas is the logical way for you to do things, that's totally fine. Then of course, if you're able to apply the same thing using a function, that's kind of, in terms of readability of the code, might be a bit easier, and also the code will be more efficient. And don't forget, was it in week 5 or 6 in GeoPython where we learned to, if you have many functions, kind of utility functions, you can write those into a separate script file and import them then in this notebook where you're demonstrating your tool, depending again on your topic. So then all these spatial data management skills that we have covered, visualizations, and then especially in here, in this final assignment, you will then kind of complete this larger workflow all the way from input data handling, pre-processing, analysis, visualizations, and reporting. So documentation and reporting is a key component of the final assignment. Yep, and then in addition, you should be able to search for information from the course websites, first of all, and then of course from the Python package documentation, from Stack Overflow, wherever. So know how to formulate your Google searches when trying to solve some problem, and then apply these methods in your code. So feel free to find examples online, but then also do credit if you find like a code snippet online that you can put into your assignment. Do also maybe in a code comment or in the README file acknowledge the sources that you have used. Yep, version control is important. I probably won't go to the level of checking how many commits and commit messages you made, but for example, it just helps you to structure the work, and I will expect to see, for example, when you submit the last commit, it might have something that like submitting for or final submission, or anyway. So version control as such is important, and it's also part of documenting the workflow for yourself and for anybody else then who will afterwards check your work. So commit often after each major change. Yes. So documenting communication, and this covers the kind of the whole repository. So your Jupyter notebook file, potential script file, and then the markdown file, and then perhaps additional data folder. So it should be, when I or anybody else goes to your repository, it should be clear where to start looking at the code, and first getting an overview and then being able to run the code. And then, yeah, well, it's kind of these self-regulatory skills. So there are now these 2 deadlines. Of course, as mentioned, I know that it's not the easiest year for everybody. So if you need some special arrangements with the deadlines, don't hesitate to ask, because if you're this far following the course, you have done a lot of work. So I would really love to give credits to all of you who are still with us doing the course. Yep. So basically, the task is to develop an analysis workflow, GIS analysis using Python, and often a GIS analysis would include, well, first you need to search the data maybe, and then do some pre-processing of the data, then the actual analysis. It could be network analysis, overlay analysis, or some calculations, whatever, combining data from these different sources. So in this course, we haven't done any like super fancy analysis, but having well-justified analysis steps, data manipulation steps in there will be enough. And then finally, somehow, if you have a clear question related to the topic or more a tool-like approach, it should then include some type of visualizations. It is at the end a GIS course, so would love to see a map if it only fits the topic. Yep, and I'll talk a bit more about this. There are maybe two approaches you can take, so it can be more of this like a case study that you report in the Jupyter notebook. You kind of make a storyline out of your data analysis workflow, or you can then make the final assignment more as a tool, which you then demonstrate for some specific case. And if that's unclear, I'm happy to show you some examples a bit later. What else? So what to submit? So you will have this GitHub repository. There's a README file. I'll show it quickly to start with. So you can submit the work as one or several Jupyter notebook files with very explanatory names of what is their role in your workflow. And you might have one or several Python script files for if you have a set of functions, or you can even do the whole work using script files, but then make sure that the work is also readable. And then you should modify the existing README file to shortly contain all relevant information about the work. So here the point is not to write an essay about the thing, but just to have these like on the title level or using bullet points, the main things. What data did you use? Where can I find the files associated with the submission? What are the main results if you use some references and so on? And then here's a note. In case you are using, for example, some big bunch of satellite images or something, larger data set, don't upload it to GitHub, but you should provide, maybe you can take a subset, a small data, based on which you can then demonstrate the idea of your workflow. And some of you will be using the travel time matrix data, so then it might be a good idea to have maybe one or two, couple of these travel time matrix files so that you can demonstrate that the tool is able to process multiple files and could be then extended to a larger amount of data. But do document in case you don't have the data, and hopefully you could also perhaps automate the data download. That's not strictly necessary. And a reminder to use informative variable names, comments, docstrings, and so on. To sum up, anyone who gets me or whoever else, Dave, could have a look at your repository and should be able to run your code with kind of minor modifications and information about the required packages. So using the environment we are using in this course, and to read your code. And these are equally as important. So even if you have made something super awesome and efficient, if it's not in a way understandable what's happening, then that's then a bit of a minus. Yep. Yeah, so then there's, well, this is mainly for me how to then systematically grade your assignments, but maybe just to give you an idea that reading and manipulating data is one component, analyzing the data is one component, visualizing the data is one component, and then overall documentation is also an important part of the final work. And let's say if you're super overwhelmed and you don't have time to complete everything, then this will give you an idea of the point breakdown. Yes. Okay, and here's a checklist. Maybe you can check it when you're thinking of that you're done and wanting to submit. So the README should be informative and the documentation also. Otherwise, functions often have docstrings, at least a one-liner code comments, markdown if needed. There's different styles for documenting the work, but it should be somehow informative. And sometimes less is more, so it doesn't have to be long, but systematic. Have you visualized something? So indeed, I'm expecting to see some maps. Can be static, can be interactive, depending on what works. Does the code work? Just are we able to run your code? And is it easy then to take your workflow and with minor modifications to apply it on some other area of interest or some other similar type of data? And then something about avoiding unnecessary repetition, using for loops, functions, different approaches. And then of course, it's a bit more subjective, but especially if you have your own topic, I will of course then look at how the difficulty level of the work affects the overall assessment. But maybe I know that students in this course are often very enthusiastic and ambitious, so also don't do too much. The point is indeed for you to learn and to demonstrate the skills we have learned during the course. Okay, we could soon have a look at the repository. Just to note that there's, well, one important part is at the top. So if you submit, especially for the first deadline, go and cross this check mark. So I will check that then early in January and grade those for the first deadline. And then for the rest, there's some instructions, but when formulating your final submission, you can remove this part, and also you can modify this section according to your structure. But these are kind of here for slots for you to fill in. And you could even already today, like start doing things iteratively. You can already today write down your topic in the README if you know what you will be working on. So don't leave this as the very last step. Planning often helps even before writing a single line of code. And then, well, then there's some general maybe guidelines or starting points for the work. So most of you have done the GIS courses here in Kumpula, but just to give you a general idea, what do I mean by GIS analysis workflow? So indeed, we might have some input data, some processing steps, and then outputs could be some tables, CSV files, maps, graphs, whatever. So keep this in mind when planning the different components. And one of the predefined tasks is related to the travel time matrix. And you can think of the process, for example, like that for several or for any of these travel time files and for this grid shape file, your workflow will do a table join, compare some travel modes, visualize the data, which will end up in map outputs, and the table join will end up as an intermediate file, which will then get more information from this process. So if it helps you, I'm not requiring a kind of workflow or this kind of flow chart drawing, but if it helps you, feel free to do something like this in PowerPoint or wherever. So this information is also in the slides, but maybe it's now easier to show it from here. And you should now see the website final work topic section. So we have 3 predefined topics for you to choose from, or kind of topic categories. The first one is called the Access Viz tool, which is kind of a well-defined, predefined tool that will then take the travel time matrix data, do some processing for it, and then visualize the data and compare travel times by different travel modes basically to any destination in Helsinki, but you can then demonstrate how this tool works using 2 or 3 files. So that is, as you might guess, a topic where you can recycle and reuse some of the codes you have already been working with in the weekly exercises, but now just kind of putting these things together all the way from reading in the data then to visualizing the data. Okay, so that's one option. And if you're kind of not feeling super inspired about inventing something on your own, it's an excellent topic then to work on. And you can also, if you want to make kind of a modified accessories tool, kind of a bit your own version of this tool, feel free to do that as well. Okay. Then the second topic, well, it's called urban indicators, and it's a bit more loose as a definition, but basically there the task is to create a workflow that calculates some metrics related to the urban structure or urban regions. And then this workflow could be repeated to different urban areas, perhaps in Finland or even in the whole world, depending on the data you are using. And this one you can do, it can be more like a kind of geographical report. So it doesn't have to be so tool-like, but still the workflow should be such that you can easily apply it to any other region. Or then you can really make a tool where you can then, by changing the city, you can then calculate all the things. I'll maybe show an example of that as well. And then indeed, the third option is to propose your own topic. So if you're working on a master's thesis, PhD thesis, take this opportunity to spend some time on automating part of the analysis related to your work. So that could be anything, almost anything then, but of course with a geographic dimension, hopefully. Okay, I can talk a bit more about these topics, but just to reiterate the structure so a bit depending on what you choose, but in general, the submission should have indeed the components related to data acquisition, data analysis, and visualization. And throughout, then good documentation. So these are then also the components that we will be assessing. Next question. Yep, so this one I mentioned, it's the GitHub repository deadlines are there. I hope, well, this is a bit poorly formatted, I'll fix that. So still about the grading. So, well, the grade is based on 60% on this final assignment, 40% on the course exercises. So basically, the most weight will be on the final assignment, and then depending on if you're kind of in between grades, then the weekly exercises might then affect the final grade, but I'll then provide the point breakdown that then forms your final assessment. Yep. Maybe I'll still show this GitHub repository at this point. So regardless of the topic, this is where I then expect to see your submission. So there's this README file. And I guess this is some fancy tool I have added for providing you feedback in some new way. So eventually, when you're finished, go to this editing mode and then just put this X in here. If you forget it, I will anyway then check your submissions after the final deadline. So don't worry about that. Oops. Let's go back. So you can read still more instructions in here. finally, you can delete this part altogether, and then down here, do start already now filling in your details. So that will really then help you to proceed. I think I actually today still edited this front page just a little bit, especially related to the references. So you don't have to put too much effort in there, but it's good practice to credit just for your own documentation and also for good scientific practices to credit the sources. So if you, well, you might have some scientific literature depending on your topic, but then just these like links to websites or tutorials or other resources you have found useful in your work. So do list them in here or somewhere in your notebook. And finally, you have been now working in pairs. This is a individual assignment, but of course, might be nice to work together with somebody. And if you do, please mention it down here. So acknowledge your friend or course mate if you got help from somebody else. So that will then help resolving questions related to, well, plagiarism or too similar code in several submissions. Of course, especially if you work with the AccessWIS topic, the solutions might be similar, but still writing code is kind of like the handwriting. So it's quite unlikely that you would choose exactly the same variable names, exactly the same order of doing things if you have really worked on your own. So feel free to collaborate in a way of supporting each other's learning. So I trust you in that sense, but do then mention if you worked with somebody with the final assignment. So that's it. I have already been talking quite a lot. I could still scroll down here. There's a lot of text, so I won't read everything through, but there's some specifications of, first of all, the input data and the structure of it, and then these components of the AccessWIS tool. So you can structure, you could have a script file for these, or you can have everything in one notebook, or you need to decide how you want to implement this. But one component should be this kind of file finder that finds specific files from this list of 13,000 potential input files in the travel time matrix. Second component will join the attributes to this grid that we have already done in the exercises. Third, a component will visualize the data. It can be a static map. Yeah, it can be either static or interactive, and could preferably then write the map to a file, for example. And then the fourth component should compare travel times between travel modes. So for one destination, you can, for example, compare travel time and car. Yes, so somebody's asking if this should be an actual tool in a sense of Python package. No, because we haven't learned that. If you want to develop it kind of as a package that you can import, or a script file, set of functions in a script file that you then import and demonstrate, that is of course a very good way to do it. But there are different ways in which you can complete this assignment. So of course, as it is kind of this tool-like thing, you will most likely want to write these different components into functions. And if you do that, it's best then to put those functions into the separate script file that you will then demonstrate, for example, in a notebook or an additional script file. I hope that answers your question. And then there are some additional components. Well, it says if you are pursuing the highest grade, maybe yes. So then there's some additional option for an interactive map plotting, visualizing the travel mode comparison. So this fourth, it's quite a lengthy explanation, but that will basically I think here the goal was only to calculate the information and store it into a file. And then based on that component, you would then visualize those changes. And then there's something else, even comparing data across years. So you could then design a folder structure with the data from the different years. So read these through. If you don't, it's a bit lengthy explanation, and it has been developed now during the year. So if you don't get the assignment, I'm then happy to even modify these instructions based on that. I think last year it went quite fine, but do think about it now, and then we can return to detailed questions also on Friday. And then there's some hints and additional information. So this AccessWIS is the most instructed one. So in a way, you can just start doing it, and it will definitely then support your learning linked to the tools that we have been now learning during these 6 weeks. Then shortly about these urban indicators. So again, it says to develop an urban analytics tool. So you can have a set of functions that you then demonstrate in the notebook. That's a good structure to have. Or then you can have this like more of a analysis workflow type of thing where everything happens inside the notebook, starting from data analysis, ending up in visualizations. So basically, the idea would be to calculate these metrics, depending on their kind of level of difficulty, you can choose some of these indicators. So there are some examples, but feel free to also choose your own. So this urban analytics tool or workflow could focus on population distribution and demographics. So for example, visualizing on postal code areas or municipalities or other administrative units, some population data, do some calculations and creating maps out of those, something related to population change. And then this could be, for example, well, of course, you could do it for all municipalities in Finland, or then for selected municipalities. Things related to accessibility. So of course, the travel time matrix is then only available from Helsinki, but there you could then, the tool could be able to repeat the analysis for different districts. Questions related to green area, area calculations, even accessibility analysis. Street network metrics, so things related to OSMNX. And there I again recommend watching the video where Henka is interviewing Geoff Bowing. Questions related to the built environment, building density. So these you can also then do with OSMNX. Okay, thanks, Gereon. Yeps. And then there's some further instructions for how to structure the work. But here you can take some, these are suggestions, so you can take some liberties. And for example, if you then get excited about one of these topics and it feels kind of enough for a final assignment, you don't have to force in some additional analysis steps. So you can always then ask me or Emil or Sonja if you're unsure about how to plan the work. And here it would be preferable because it's more applied, more about getting some insights. So you could add then some short observations. If you plot a map, what can you see there? And then of course the data sets might have limitations, so you can add short descriptions about those. Some more inspiration. And then finally, your own project work. So probably it would include acquiring the data pre-processing data, analysis of data, and hopefully some visualizations. So if you will choose something totally on your own, you could maybe send me a Slack message by Friday or even later, but hopefully on Friday. So then I can on Friday spend some time checking and giving some feedback on the topics. All right, so I think that's now it for the final assignment introduction. There's still some additional hints. I wonder what we even have in here. Yeah, well, maybe this is a nice thing to wrap up. So really good to take some time and to plan a bit what you will be working on, and to remember the point why we are learning programming. So of course we might spend a lot of time developing some tool, and eventually we would have been just quicker doing the things in QGIS. But of course the point is to hopefully automate some processes that would otherwise be error prone and slower, or even impossible to do without programming. What else? Make incremental changes, and here using Git will help. So try to always leave commit messages that are clear. And then also then maybe this point 6 is important. So of course we are learning all the time. So if it works, we are happy, and then afterwards you can see if you can make it a bit more efficient. And then documentation is important, but don't overdo it. So should be clear and purposeful. And feel free to collaborate, but as mentioned, then do acknowledge the help you receive. All right, so with that, I end this recording, and I wish you all the best for the final assignment, and we will then continue with any questions you might have.